Hi, welcome back. In this video, we're going to talk about translations. Now, translations is really just known as a shift. It could be a vertical or horizontal shift. When you merge those two together, right, and you form a horizontal and vertical shift, we can actually introduce a new topic here called a vector. Now, we're not going to go too into the specifics of a vector, but we're going to use the notation here, vector notation, as a comma b, where a represents what is happening horizontally and b represents what's happening vertically as we're shifting a polygon left, right, up, or down. So we start with our original point, x comma y, and then we'll talk about this horizontal shift. So what we could really talk about is a will affect the x value, so we can say this is going to be x plus or minus a, because we're moving to the positives would be plus a, or to the negatives minus a. And we can also talk about the vertical shift, which is going to be y plus or minus b. Again, positive meaning it's moving up, and negative meaning it's moving down. So when you see this notation, we're really describing how is it affecting it horizontally and vertically. So let's say we begin with this quadrilateral TUVW. I'm going to show you how to do this translation using vector notation and how to do it using the graph. So let's plot the points first. T is a -3, -8. So we're going to go -3, -8. Keeps moving me. It's not wanting me to do it. -3, -8. I'll try it one more time. This is T. -6, +3. This is U. 0, +3. This is V. And 3, 0. This is W. Now this quadrilateral is going to be shifted using that vector. So what does that mean? It means that since we have a +4, we're going to be moving 4 units to the right. And since we have a +5, we're going to be shifting this unit 5 units up. So you could literally go onto the graph and count 4 spaces to the right, 5 spaces up for each point. I can start with V. 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5 up. And I can call this V prime. That's the shift that I went through. So V will be located at 3, 8. Now I'm not going to go through the answers just yet, but that's where we plot that point. I can do that for all of them. W goes 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5 units up. That's W prime. With U, 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5. Here I have U prime. And then T prime would be 1, 2, 3, 4. 1, 2, 3, 4, 5. This is T prime. Notice how when I connected them, my image shifted to the right and up at the same time. Together, we can talk about how this is a vector shift in that direction. It's moving diagonally to the right. How do we use, this is how we do it algebraically, right? We count this, this is how we do it graphically. We count the spaces to the right, how many spaces up, plot the point where it lands. Algebraically, we're going to want to use the fact that it's +4. So we're going to say the x values, we're going to add 4, since +4 moves to the right. And the y value, since it's positive 5, we're going to do plus 5, right? Under the assumption that we recognize it in a graph. Positive values are to the right, negative values are to the left. Positive values are pointing up, negative values are going down. Okay? So all we do is I can plug in these points into here. That's really what we can do to solve this, right? Algebraically. So I'm going to move negative 3 plus 4, and then negative 8 plus 5. And I can see how that point will be positive 1, negative 3. Notice how t is at positive 1, negative 3. And that's where t prime lands. U, I would do a similar thing. I would do negative 6 plus 4. Let's do a different color. Negative 6 plus 4. And then the positive 3, we're going to do plus 5. When I simplify, negative 6 plus 4 is negative 2. 3 plus 5 is 8. And that should be the location of u prime. For v, I'm going to do 0 plus 4 and 3 plus 5. This remains unchanged, right? The vector movement will be true for every single point. So for v prime, we land at 4, 8. And you can verify these points on the graph. Lastly, we have w prime. That means we're going to start at 3, 4 to the right, starts at 0, and 5 units up. So w prime will land at 7, 5. And that's how we find how this shifted. Let's try another example. Here we can do it on the graph. We can also plot it. Our goal here is to follow this vector notation. The first value represents the horizontal shift. Since it's a positive 3, we're going to say that this is going to be x plus 3. And since it's a negative 2, we're going to say that this is a vertical shift in the negative direction, so y minus 2. All I really have to do is go to the points and then do 1 plus 3 gives me 4. 6 minus 2 gives me 4. So if I plot A, I start with A at 1, 6. This is the original A value. And when I move it over, I'm going to land at 4, 4. 4, 4. Notice how I moved to the right and down. 3 spaces to the right, 2 spaces down. And I can go through that for all the points, right? When I look at B, I'm going to do 4 plus 3 gives me 7. 5 minus 2 gives me 3. I have A prime, B prime, C prime. 1 plus 3 gives me 4, and then negative 1 minus 2 is negative 3. And lastly, D prime will land at negative 2 plus 3 is 1, and 0 minus 2 is negative 2. And I can plot all of these points and see how it's shifted. So let's do the original one in blue and the new one in red. So I have 4, 5. This point is B. 1, negative 1. This point is C. And negative 2, 0. This point is D. It seems like we have a bit of a rectangle here. Assuming that my lines are straight, we're going to move this over and you can see where it belongs when I plot the other points. 4, 4 I've already plotted for A. 7, positive 3. This is B prime. 4, negative 3. This is C prime, and 1, negative 2, D prime. And there it is. Notice how we moved every point to the right and down. Now let's say that we are given the two images. Remember that from our previous video, the original capital letters, I'll do this in red, the original capital letters represent the original image. When you start putting a tick mark or prime, A prime, B prime, C prime, that prime or that tick mark, that apostrophe represents the new image. We'll call this the original image. We'll do it in red, I guess. So I say congruent. I have the original image, and then I have the new image, the pre-image and the image. So our goal here is to figure out what vector was used to translate the original image to our new image. What happened there? And all I really have to do is follow one of the points. So let's start with this point. Let's count point A to A prime. How did we get there? We went 1, 2, 3, 4, 5 units to the left. So in the x direction, remember this represents x and this represents y. In the x direction, we moved negative 5 units, 5 units to the left. In the y direction, we moved up 1, 2, 3. So it's going to be positive 3 since we're moving upward. And I can check for all of them, right? I can move to the left, and then I move up 3 units, or I move this one to the left, and then up 3 units. They're all going to follow this exact same vector. Now let's say that here, we're told that ABC was translated along this vector. Now we're going to assume that this is just a negative 5, okay, comma 2, onto this vector. So this is the location of the new one. Notice how this has a prime, A prime, B prime, C prime, which dictates this is the new image. We're trying to identify, given this vector, what is the original? If that's what happened to it, where did it come from? Right? And there's different ways to go about this. You can set up an equation algebraically. You can also just sort of look at the graph. Let's go about it 2 different routes. I know that I moved 5 units to the left and 2 units up to get here. So I have to go in the opposite direction. If I went 5 units to the left, I'm going to reverse this. I'm going to go 1, 2, 3, 4, 5 units to the right, because I'm trying to predict where it came from. And since we moved 2 units up, we need to go backwards. We're going to do 2 units down. That means that my original point started here. It went up 2 units and then over 1, 2, 3, 4, 5 units to the left. Right? And this point is at 1, 1. To find B, again, I'm going to go backwards. 5 units to the right. 1, 2, 3, 4, 5. And 2 units down. This is the original point B. And B is located at 3, 4. And to find C, we're going to go 1, 2, 3, 4, 5. 2 units down. This is the original C, which is located at 5, 2. So you can confirm by looking at the original points and affect it using the vector. Can I take A and say, to get A prime, I can say 1 minus 5 and 1 plus 2. That would give me negative 4, 3. Is that true? If I go negative 4, 3, yeah, that's exactly where we landed. So we're really working backwards to figure out if this was the vector that got us here, where did it start? Graphically, that's probably the most straightforward way to go. You work backwards from the vector. So you want to change the signs. This would become a positive 5, and this would become a negative 2, since you're working backwards. Algebraically, you can set up some sort of equation. If I know the outcome is supposed to be at negative 4, 3, if I know point B prime is at negative 2, 6, and I know C is at 0, 4, I can set up an equation to find out what got us here. I can say the A value, the original one, will be x minus 5, right? And the y value should be y plus 2. This should take me to negative 4, and this should take me down to a positive 3. So I can set up this as two different equations, right? X minus 5 equals negative 4, and y plus 2 equals 3. When I solve for x, by moving this over, I do the opposite. I get x equals 1. When I move this over, I do the opposite. I get y equals 1. This tells me the original point, which is true. That's exactly what we said, right? We said we could figure out the original point using an algebraic equation or by using the graph. So what is it that I did here? Let me explain this with using a different point. I'm trying to find the original point knowing the outcome. To the original point, I'm going to subtract 5 on the x value. This comes from here, from the vector. The original x value, if I take away 5, I should land at negative 2. That's the x value of the new image, right? So B is I take whatever x value I have that I'm trying to predict, subtract 5, and I should land at negative 2. And when I move this over and I do plus 5 on both sides, I'm going to get x equals positive 5 minus 2 gives me 3. That's going to be the x value of the original point. If I want to find the y value, now I got to focus on the y vector. So the y value, since it's plus 2, I'm going to add y plus 2, and that should give me the answer, or the location, which is positive 6. Original plus 2 needs to give me 6. So when I solve for y, I get y equals 4. Notice how 3 comma 4, if I were to merge these two, Three comma 4 is the location of the original point. Right here. So you can set up an equation algebraically, or you can just count at the graph by working backwards. Instead of a minus 5, you're going to do 5 to the right. Instead of positive 2, you're going to go 2 down, because you're working your way backwards to find the original location. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate later.